In this lesson, we will look at relationships between zeros of polynomials and the coefficients of the polynomials. So let's first look at a linear polynomial. The general form of a linear polynomial is p of x is equal to ax plus b. In order to compute the zero of this polynomial, we equate p of x to 0 and then find the value of x. So if you put p of x equal to 0, as you have seen here, then ax plus b becomes 0 and x is nothing but minus b by a. Here minus b by a is the zero of the polynomial or root of the polynomial, right? So if you observe here, the relationship between 0 and the coefficients of this polynomial is, so here a is the coefficient of x and b is the constant term. We will also consider the constants in the relationship. So over here we have minus b by a. So where b is the constant and a is the coefficient. So that is the relationship between 0 of a linear polynomial and its constant and coefficient. Next we will look at the relationship between zeros and coefficients of a quadratic polynomial. Okay. So let's consider the quadratic equation ax square plus bx plus c. So that is the general form of a quadratic polynomial. Let's take an example, 2x square minus 8x plus 6. So if you remember from your 9th class lecture of polynomials, we have discussed that in order to factorize a quadratic polynomial, we will take the middle term and split it into two terms such that the sum of those two terms is equal to b and the product of those two terms is equal to AC. So here a is equal to 2, b is equal to minus 8, c equal to 6. We have to split minus 8 into two parts such that the sum of those two parts, let's call it as b1 plus b2, is equal to AC. Right? So here we can split minus 8 into minus 6 and minus 2. If you split it that way, then the sum of these two is equal to minus 8, which is b, and the product of those two terms is minus 6 times minus 2 is 12, which is nothing but AC. AC is 6 times 2, which is equal to 12. So that's exactly what we have done here. So we have split minus 8 into minus 6x and minus 2x. So now taking 2x as common, you will have 2x times x, which is 2x square, minus 3, which is minus 3 times 2x is minus 6x. Similarly, taking minus 2 common in these two terms, you will have x minus 3. So this is nothing but 2x minus 2 times x minus 3. You can take 2 common in the first term and it becomes 2 of x minus 1. So if you observe now, this is in the form of k x minus alpha and x minus beta, where alpha is 1, beta is 3 in this case. When you factorize a polynomial, basically what you are saying is those factors when equated to 0 will give you the roots of that polynomial. Here x minus 1 is a factor of px. If you equate that to 0, x equal to 1, right? So when you substitute x is 1 here, this term becomes 0 and the product of any term which has 0 is 0, which means p of x is 0 and the value of x when p of x is 0 is the root of that polynomial, right? So when x is equal to 1, this whole value becomes 0. Similarly, when x equal to 3, the whole value becomes 0 because 3 minus 3 is 0. So 1 and 3 are the roots of or zeros of this polynomial p of x. So let's consider alpha and beta are the roots of a general polynomial ax square plus bx plus c. So this can be expressed as p of x equal to k times x minus alpha times x minus beta, where k is a real number and it's a constant. As you have seen here, in this case k is 2 and alpha is 1 and beta is 3. Okay. So now let's look at how we can derive the relationship between the roots which are alpha and beta and the coefficients a, b and the constant term c. So now let us assume that alpha beta are the roots of the quadratic equation ax square plus bx plus c, and we have just seen that p of x can be expressed as k times x minus alpha times x minus beta. Now let's try to multiply these two terms. So x times x is x square, x times minus beta is minus x beta, and minus alpha times x is minus x alpha, and minus alpha times minus beta is plus alpha beta. Over here you can take minus x common in these two terms, and you will have minus x times alpha plus beta, and the rest of the two terms are still same. So now let's multiply each term with k, and you will have kx square minus kx alpha plus beta plus k alpha beta. So this is nothing but this is equal to p of x, but p of x is nothing but ax square plus bx plus c. So equating the coefficients, we have a is equal to k, b is equal to minus k times alpha plus beta, and c is equal to k alpha beta. So if you observe this, now alpha plus beta is nothing but minus b by k, because taking minus k on the other side you will have minus b by k, but k is nothing but a. So this is equal to minus b by a, and alpha plus beta is sum of the roots or zeros. So sum of the zeros of a quadratic polynomial is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. Similarly, alpha beta is nothing but c by k, taking k on the other side, but k is nothing but a, so it's equal to c by a. So alpha beta is product of roots or zeros. So the product of roots of a quadratic equation is equal to c by a, where c is the constant and a is the coefficient of x square. So this is the relationship between the roots and the coefficients and constants of a quadratic polynomial.